All right, today we are pulling back the curtain on one of the most important and honestly most misunderstood roles in all of tech. We're going to spend a week in the life of a cloud architect to find out what they actually do. You hear this title thrown around all the time, but what does it really mean? Are they just sitting in meetings drawing diagrams? Are they coding 24/7? What makes them different from, say, a senior engineer? Let's finally answer that big question. What does a cloud architect really do all day? Okay, here's the best way I've ever heard it put. Think of a cloud architect as the conductor of a huge, complicated cloud orchestra. Now, they're not playing the violin. That's your software engineer, right? They're writing the actual code. No, the architect is the one with the master plan, making sure every single piece, from the AWS servers to the Azure databases to the Google Cloud Network, all plays together perfectly to hit one single critical business goal. And that gets right to the heart of their job, creating the blueprint. Their entire role is being that bridge, the person who translates what the business wants into a technical reality that actually works, stays online, and doesn't break the bank. Now, this is where it gets really interesting because look at the sheer scale of the playground they get to work in. An architect's palette isn't just, one color. It's this whole spectrum of options. They have to be fluent in all the major clouds. They need to know exactly when to use an AWS EC2 instance for compute, but maybe pair that with Azure Blob Storage for photos or a Google Cloud SQL database for the really structured stuff. It's this multi-cloud fluency that lets them build the best solution, not just the one that's easy. And this is so crucial. It's never about technology just for the sake of technology. Nope. Every single decision an architect makes is measured against these three pillars. Is it resilient? Can it take a punch? Is it scalable? Can it grow with us? And is it cost effective? Because at the end of the day, the goal isn't just to build something cool that works, it's to build a technical strategy that helps the business win. Period. All right, so that's the theory. But to really get it, we need to get into the trenches. So let's make this real. We're going to walk through three critical, high-stakes decisions that a cloud architect faces almost every single week. First up, we've got a challenge that keeps business leaders up at night, the classic scalability problem. So the pressure is on. Marketing has this massive campaign teed up, and next week, a huge product launch is going to drive 10 times the normal traffic to your website. The directive from the CEO? It's simple and it's absolute. The app cannot, under any circumstances, fail. And this right here perfectly illustrates the world of trade-offs an architect lives in. There's no perfect answer. Option A, you could go with proactive over-provisioning. Just buy way more server power than you think you need. It's safe, availability is pretty much guaranteed, but wow, is it expensive. Then there's option B, reactive auto-scaling. You set up rules that automatically add more servers as traffic ramps up. It's way more cost efficient, but there's a risk. If that traffic spike hits faster than your system can react, users could get lag, or even worse, the whole site could crash. The architect has to weigh that business risk against the cost and be the one to make the final call. Okay, so the immediate fire from the launch is handled. Now let's look at something more long-term, a really foundational decision. Next up, the product team wants to launch this amazing new feature. It'll let users upload, store, and tag millions of photos. So the business need is simple, a solution that's fast, reliable, and can handle just a mountain of unstructured data. The architect's first question is the big one. What kind of database are we going to use? And again, it's a real dilemma with no single right answer. They could go with a traditional, super reliable SQL database. It's structured, it's solid, but it's not super flexible for things like photos and random user tags. Or they could go with a modern NoSQL database, which is literally built for this kind of scale and flexibility. The catch? It works on a totally different data consistency model that the whole engineering team has to learn and adapt to. This one choice, it's going to define the foundation of this feature for years to come. And for our third and final weekly challenge, we're going to move beyond just performance and data and into the really complex world of global regulations. The business is going global. They're expanding into a new region, but this one has really strict data privacy laws. Think Europe's GDPR. This is awesome news for growth, but it's a massive technical headache. The business need is crystal clear. Operate legally, and whatever you do, avoid those crippling fines. So how do you design a system that stays compliant across all your different clouds? This is what I like to call the security standoff. The architect could use the platform-native tools from, let's say, AWS. They're powerful, they're deeply integrated, but they pretty much lock you into that one provider. Or they could invest in a third-party security suite that works across all clouds, giving them this amazing single pane of glass for their whole security posture. That offers incredible flexibility, but it adds a whole other layer of complexity and cost to manage. This decision isn't just about tech, it's about the company's strategic freedom down the road. So we've seen the kind of big picture decisions an architect makes. Now let's talk about the pitfalls. Let's look at two very common and very, very costly mistakes that you see a lot from junior engineers or people just starting on the architect path. There's this great quote from a senior architect that I just love because it's so true. The cheapest server is the one you turn off. The cost of a small oversight can be astronomical. And that leads us straight into the first huge mistake. So what's that first major mistake? It's one that hits the company right in the wallet. Ignoring the bill. Because the cloud feels like this infinite magical resource, it is so easy to spin up an oversized server just in case. Or maybe you create a super complex test environment for a project, and then you just forget to shut it down over the weekend. The result? A truly jaw-dropping cloud bill at the end of the month. A great architect is just as much a financial steward as they are a technologist. And if that first mistake is all about immediate cost, the second one is about a hidden cost, one that can absolutely cripple you years down the line. Chaining yourself to a single cloud. It's often called vendor lock-in, and it happens so subtly. You start using a provider's really cool proprietary service that has no equivalent anywhere else, then you hard-code their specific APIs right into your application. And before you know it, when a competitor comes along with better pricing or some game-changing new feature, moving is no longer an option. It's become this massive, multi-year project. A strategic architect is always, always designing for a multi-cloud future. So after this pretty intense week, what's the big takeaway here? What does it really take to build a career as a great cloud architect? It really all boils down to cultivating the right mindset. You have to learn to think in trade-offs, not in absolutes. It's almost never about the best technology, it's about the right technology for a very specific problem. And that means you have to understand the business goals first, before you even think about a server. You have to weave cost and security into your design from day one, not tack them on at the end. And you always, always design for a future where you can use multiple clouds. In the end, the role of the cloud architect is to draw that map that turns a business dream into a technical reality. The blueprint is there. The only question is, are you ready to build?